This is a solutions video for test over chapters 1 through 3 in statistics the spring of 2014. This is somewhat reworked but had a lot of similar questions from previous semesters. There was 58 points. The high scores were missing one, but there's only one person I think, but there's a lot of missing two. So I gave everybody 2 points on this. And so let's go through the answers. And number 1 here, we test this medicine. The question is how many people are actually tested in each group, and then we need to compare the rates to figure out if it's effective or not, to see if there's a difference in the percentage that suffered from side effects. And here's a unimodal and symmetric distribution. Does it appear to be normal? It says, yeah, it looks pretty normal. And then this last question a lot of people missed, or is a little tricky. It says, what do you think is higher, the mean or the median, and why? Well, what's interesting, a lot of people had unimodal and symmetric, but then they would pick one to be higher or lower. If it is unimodal and symmetric, the mean and the median should be almost identical. So that's what the answer I was looking for. It's about the same. I did allow some people, because it does look like it tails a little bit here to the right, slightly skewed to the right. So you could say the mean would be pulled that way. So I did accept that if you said the mean, but you had to explain why. You had to say something like it is slightly skewed right, or there's a few something the skewness of the right to get the full credit. But this to me looks pretty symmetric, and also the mean and median would be about the same. Number 3, it says which of the following are changed by adding 2 points higher. So if I add 2 more numbers to the list, that's definitely going to raise the mean and the median. It's also going to add the variation because those are on the end. It's going to add the standard deviation and the range. The interquartile range probably would change if you had a bunch of values that were identical around there. It may not change, so you didn't have to have that. Probably would change, but wouldn't have to change the interquartile range, because the quartiles may stay the same if there's a lot of repeat values near those points. But so in general, I was looking for all of them would change. Number 5. I had some trouble with this one, and I think that was kind of due to my error. I don't know if I explained this very well or didn't point to it. So that's one reason I didn't feel too bad about giving a little credit back. And this one, it says, who are the subjects? The subjects are the math students. That's the people being studied, are the students. The experiment, what's the instrument? How do we measure if they're learning or not? And that would be the tests that are given. And the third one is, what is the variable of interest? We're checking to see which teaching method is better. So that's the variable we're manipulating here. And then 2 examples of confounding variables. So these are some other things that might explain variation in these test scores. Have a lot of good ideas. Might be the 2 teachers might be really different. Maybe the 2 types of classes are much different as far as the diversity of students in the classes, maybe their learning or their intelligence or their attitudes. Might be what time of day, how big the class sizes are, how much, there's lots of other things that might explain variation besides the teaching method. And 5 and 6, they've got a new lubricant. They tested on one, and they tested against the old one. So this is definitely an experiment, because you have a control and a variable we're manipulating. On number 6, we're just taking a poll of people. We're not manipulating any variables here, so this is just an observational study. On 7, almost everybody got this. It's misleading because there is no true zero down here, so you'd redesign that with a true zero. Without the true zero, it exaggerates these differences. Number 8, just a histogram here. Make sure you have the age in the horizontal, frequency in the vertical. And then you just make your bars, make sure there's no gaps between them. This is a little tricky right here. If you see that 70 to 89, this actually has a width of 20. So that actually was a really wide bar, which makes this kind of messed up. But I didn't make kind of wrong if you didn't do that, but just make you aware. It's definitely unimodal and skewed to the right here. Number 9, the typical one, finding the medians. So if you look here, the middle is 52. The median is 52 right here between 50 and 54. We average those, so the median is 52. If you did add them up and divide, that's the mean. It's 52.56. Quartile 1 is right here, halfway. So if there's 8 on the bottom, 8 on the top, so it's right there. The median, the top half, is between 62 and 66, which puts quartile 3 at 64. So the least value is 30, the highest is 80. The interquartile range, the difference between 64 and 40 is 24. The upper fence is found by quartile 3 plus 1.5 of these interquartile ranges. So if that goes up to 100, so there's no outliers on the top end since the high score is 80. And the lower fence is 40 minus that same number. So 40 minus 1.5 times the interquartile range gets us down to 4. Again, no outliers that way. And there's your box and whisker plot. The only mistakes I usually saw in this is if you didn't have a scale that was kind of like unique, because you don't always write the numbers in there and not have it referenced to a standard scale. On 10, this is the z-score one. Just find the z-score of this day, and it's negative 1.92 standard deviations below the mean. So you just find the difference in how much they made divided by the standard deviation. So what's the percentile rank? If you look up negative 1.92 on the z-table, you get 2.74, and the z-table gives you the area below. Let's see here. So if I look up negative 1.92 in the z-table, let's do that real quick. Negative 1.92 puts this right out here. So there it is. Puts us at 0.0274. That's the percent that is below that particular one. Is that unusual? In general, our book has been saying 2 standard deviations below the mean. So we're going to say no on that. A few of you said, well, it's below 5% because it's one-tailed. I'm like, if you explained it that way, I did give you credit. On 11, again, another one where we find the z-score. It's 3 standard deviations above the mean, and I did take off if you did not draw these pictures. It says draw a picture for each scenario. So you need to draw the normal distribution with the mean in the middle, 91 up here. If we look up 3 on our z-table, so let's do that. If we look up positive 3, that puts us right here, 0.9987. Well, we want the area to the right, so you take 1 minus 0.9987, you get 0.0013. So there's the probability that's higher than 91. And then what's the probability it's between 19 and 91? And these are both 3 standard deviations. So draw that picture. If you look at 91, the area below that is 0.9987. The one below negative 3 is 0.0013. The same answer that was to the right of 91. So the difference is 0.9974. You can find the difference between those two. And then what's the z-score? A lot of people miss this one. The z-score, the top 10%. So we want to find the top 10%. Draw this picture, that helps. We want to find out what's the z-score for the top 10%. So if I go here, I'm looking for the top 10% in the body. And that puts us about right here, 1.29, or 1.28, 1.29, anywhere in there. I accepted either of these. So you got to go about 1.28 or 1.29 standard deviations above the mean. And so you need the picture in that. And if you actually calculate it, a few people actually did that, solved it, and it looks like $70.48 would be that cutoff for the top 10% phone bills. 12 was 85th percentile versus 85%. Most of you got that. 85% is based on standard. 85% of the questions answered were correct. 85 percentile is a norm referenced, or comparing to everybody who takes it. It doesn't have really anything to do with how you did with the questions. It's just comparing you compared to everybody else, or Marla compared to everybody else that takes the exam. 13 was a little picky on this. I want to know what's the largest and the least variation. There's our standard deviation formula. If you look at set A, they're all the same, so there will be no variation. So yeah, if you said the least would be A, but you say why, you could say there's no variation, or the standard deviation would be 0. And then the most variation is going to be C, because on C here, we see that there's many more numbers that are farther away from the middle. So something that's just more data away from 30, or more away from the average, that's going to cause more variation. And then 14, it just says find the mean and standard deviation for the data. And so most people did this very well. Some people forgot to square and get all positive numbers here, but that's 5.06. I need to show the work there, find the difference from the mean on each data point divided by n minus 1. Some people forgot to put the n minus 1. They left it as a 6 instead of 6 minus 1, which is 5. And 5.06 is the standard deviation. So that's about it, and hope this video helps you get ready for the final or a test in another semester.